Texas's population is growing rapidly. NAFTA-related heavy truck traffic is increasing the strain on our highways. The Texas Department of Transportation must build roads that can stand up to the heavy demands placed on them. Proper construction materials is one of the keys to long-lasting roads. Concrete is one of the materials most commonly used to build long-lasting highways. TxDOT prefers the use of continuously reinforced concrete pavement, or CRCP, because it provides a long-lasting, smooth ride with low maintenance. Since concrete cracks as a result of shrinkage during the curing process, it becomes very important to control the spacing between these cracks. Premature pavement failure will occur if the cracks are too close together. When properly constructed and maintained, a concrete roadway should last 30 to 40 years. For the past 25 years, TxDOT has monitored the condition and performance of its concrete pavements. The information collected was put into a database. Using this data, TxDOT-sponsored researchers looked for performance differences in concrete pavements. One of the original findings was that the coarse aggregate type used in concrete was a significant factor in pavement life. Aggregates come from different geological sources. Their properties may vary. Researchers studied the coarse aggregate material properties. The results were eye-opening for TxDOT. It was discovered that various aggregates respond differently to temperature changes. The effective temperature on coarse aggregate and the concrete pavement is the prime cause of excessive early-age cracking. This leads to a difference in pavement life. Placing concrete pavement during the hottest portions of the year compounds pavement performance problems.
Various commonly used aggregates were tested to see if they responded differently to changes in temperature. The result: calcium-based aggregates are generally not as temperature sensitive as silica-based aggregates. Pavements with lower temperature sensitivity calcium-based aggregates tend to crack at an acceptable spacing of around 6 to 9 feet. Pavements with higher temperature sensitivity silica-based aggregates have a less desirable spacing of 2 to 3 feet between cracks, which leads to premature concrete pavement failures. The closer the crack spacing, the greater the number of these failures per mile of pavement.
Most concrete pavements in Texas are in urban areas with high traffic volumes. TxDOT strives to use the best construction materials to ensure long life and minimize road closures. Having to close and repair a road is expensive. It causes major inconvenience for drivers and increased liability for the state of Texas. For example, closing one lane of freeway for 1 mile can cost users over $26,000 per day. Initial construction costs are usually less using local materials. However, cost-effective pavement performance sometimes requires materials that are not locally available. TxDOT discovered that materials that are highly sensitive to temperature changes cause problems with concrete pavement performance. TxDOT is attempting to eliminate premature pavement failures due to aggregates that are highly sensitive to temperature change. This graph illustrates that silica-based aggregates, because of their closer crack spacing, experience more failures. This leads to a shorter pavement life, sometimes 12 to 15 years. On the other hand, calcium-based aggregates such as limestone, with their more favorable crack spacing, experience fewer failures. Limestone aggregate pavements have an average life of 30 years. Highway engineers and the construction industry are continually developing new design and construction procedures that make the best use of locally available materials.
Between 300 to 400 million cubic yards of concrete is produced annually in the United States. 1/3 of that goes into streets and highways. The other 2/3 is used in construction applications where temperature sensitivity is usually not an issue, like bridge structures and buildings. TxDOT continually improves its road building procedures. They have to. On the state's most heavily traveled roads, traffic volumes will double in the next 10 to 12 years. Choice of construction materials is critical. Engineers must be able to select and use aggregates based on maintenance cost and overall pavement life, not just initial cost or local availability. Research continues into the appropriate use of local materials and the conditions under which they perform best. TxDOT must have the flexibility to use materials other than those locally available to ensure good pavement performance. The goal, to provide Texas taxpayers with the smoothest, most cost-effective roads possible.